Okay, again, back in the days. So, basically, straight on to the next panel, we have tackling a 200 million problem. Basically, each year, protocols lose hundreds of millions due to MEV and poor liquidation strategy. So today, with Mike Massari, that is an engineering executive with over 2 decades of experience, chain link, right? Too, and now to OEV, right? Can return to that value to the protocols. So again, big applause to Mike Massari. The stage is yours. You can talk to us. Thank you so much.
Thank you very much. Nice to see you, everybody. I am Mike Massari. As you know, I am strategic advisor at RedStone. Today we're going to talk about this tubing and problem in production, so an OEV design that actually works. Let's start with some context. Liquidations in lending protocols. Who is familiar with them? 2 people. Okay, fantastic. So whenever you have a position in a lending protocol, that position is collateralized to a certain extent. If price changes, your position may become under collateralized and get liquidated. This is what happens today in every lending protocol. If you use Compound Morpho, Aave, Euler, they're all the same. Now, the problem is that when that position gets liquidated, a knife fight begins. And this knife fight is done by MEV bots that try to race each other for liquidating the position before everyone else. And effectively, this creates a problem. It creates multiple problems. The first one is that obviously you have no money that gets recaptured in the protocol, and that's very bad. Also, you waste a lot of gas. There's a lot of transactions that get made to the chain, and so the chain gets spammed with transactions. But all the risk control is also outsourced. So overall, this isn't really a system. It's just the Wild West. And protocols actually lose out on billions of dollars of potential revenue every year. There is a better way to do this, which is called OEV, which stands for Oracle Extractable Value, and effectively switches this problem on its head. With OEV, whenever there is a price update that can trigger a liquidation, we run an off-chain auction where all the liquidators can bid for the right to liquidate a specific position. And this off-chain auction has 3 main advantages compared to the war that we used to have since now. First one is that there's no blind guessing. You know exactly once the auction finishes who's going to liquidate the position. Everything is very, very specific. There's no gas war anymore because people just bid in this closed bid auction. And then finally, you don't have duplicate transaction that are dragging the network right down. What we do is we get the result of this auction and then we batch it with the price update. We put it into a single atomic transaction and then we send that on chain. And we capture the Oracle extractable value that comes from the liquidation and we give that back to the protocol. So I'm going to take you through in the next few minutes on exactly how this works and why this matters. When we created this at RedStone, we sat down as we usually do, as we do for every problem. We do it for RWA when we talk about our RWA feeds and the talk that I did just minutes before. But we did it for this as well as we do it for everything. And we decided on 5 things that are important. And on 5 things, they are these good traits that every OEV system should have. First one, it needs to be fast. Liquidations are a time-sensitive matter. So we want to make sure that protocol don't slow down because this exists. And we made it fast in a very simple way. We are actually batching two transactions together into one. So we are sending on chain at the same time the liquidation information and the price update. So in the worst case scenario, it's just as fast as it was before. And in the best case scenario, it's actually much faster. It needs to be easy to adopt, which is crucial because I'm a developer and I'm lazy, and you guys are engineers that are also lazy. And at the end of the day, if you can implement a new system and bring revenue to the protocol without having to do code changes, without having to re-audit your contracts, without having to modify any sort of market, that's just a perk. And it makes the adoption of this much, much smoother. So the RedStone solution for OEV requires exactly 0 code changes on the protocol side. There's nothing that needs to be changed. Everything is seamless. We will talk about it in a bit. Third, it needs to be safe and secure and reliable, which for me is the most important thing. For everyone at RedStone is the most important thing. Oracles are a sensitive matter, and the topmost value of an oracle is to be reliable and is to be safe. RedStone didn't have any downtime since we started our oracle in production on mainnet. We wanted to keep it this way even with OEV. So no matter what happens in the auction, we want to make sure that the price gets always pushed to the chain. Then it needs to be permissionless and it needs to be open. And this is a very important thing because at the end of the day, I still like to believe that this is the reason why we're all here. We started this whole crypto thing because we didn't want to have permission system. We didn't want to trust central entities. And we wanted our OEV solution to be the same. We wanted our OEV solution to be open and as permissionless as it can possibly be. And finally, it needs to be cross-chain by default. So we want to make it compatible with every EVM chain. EVM is by far in DeFi the biggest ecosystem at the moment. And RedStone is on over 100 chains. Most of them are EVM. We wanted to start with the biggest pool that we can possibly start with at the same time. Very important to say that this is not just, optional polish. These are fundamental traits that a good OEV system needs to have. And we sat on either having these, all of these, or going back to the drawing table and start over again. So we created an OEV system that actually ticks all of these 5 boxes. And this is how it works. Very simply, there's 2 parts of it. There's an on-chain part and there's an off-chain part. Let's start with the off-chain, that RedStone detects a price update that could trigger a liquidation on a specific position, on a specific chain, and on a specific protocol. At that point, we partner with a company that is called Fastlane, which created this amazing system called Atlas that spins up an off-chain auction in which liquidators can bid for the right to liquidate that specific position. Step 3, we create, as a result of the auction bids, an ordered list with all the liquidators in order from the one that liquidates the position all the way down. Then we go to the on-chain part. So we batch this into one single atomic transaction, and the RedStone relayer actually sends this information on chain. In the same transaction, we have price update and liquidation information all together. Finally, once the information is actually on chain, there is a try-catch loop and a try-catch mechanism that gives obviously the first liquidator the right to liquidate the position, and then if they don't liquidate it, it goes to the second and to the third and to the fourth, so that we make sure that the position eventually gets liquidated. As you can imagine, once you bid as a liquidator for liquidating a position, you made your math and your liquidation is going to be profitable, so chances are you're going to liquidate it. But at the same time, maybe there is a problem, maybe there is something that doesn't go according to plan, so we go to the second one and then to the third. In our test, so far, we never got further than the third liquidator. Like at the third liquidator, every single position was liquidated. Most of them were actually liquidated on the first try. And the kicker of all of this is that this whole process takes maximum 300 milliseconds, which means that if there are no bids in the auction, after 300 milliseconds only, we fall back to the regular price update. So at the very, very worst, as I was saying before, we are making the chains, the protocols, the same speed that they always were. 300 milliseconds is faster than the block time of most chains. In the best case scenario, everything happens faster because you get more information within this window of time. We ran a POC for this. This doesn't just exist in theory. This is actually live today. In December, when we started this concept, we ran a POC with Venus. Venus is a very, very famous lending protocol. We ran it on a very specific market, so just on BNB chain, just for a month, just on selected price pair, because we wanted to get learnings from this POC. We wanted to bring this system to a place where we were comfortable of expanding it and scaling it up in production as we're doing now. After 30 days, there were about 19 liquidations. This was a time sometimes of quite high volatility. It was December last year, so you can remember prices were going up and down quite a bit. We captured $165,000 in liquidation volume in just a month. This is why we say this is a multi-hundreds of millions of billions of dollar problem. And we recaptured 6.44 of that volume into the actual liquidation bonus, with zero downtime, which was interesting. And, you know, I'm an engineer, so when I run POCs, I do expect stuff to go wrong. I kind of want stuff to go wrong. But in this particular case, not much did. So we sat back on the table and we were like, okay, fantastic. The system works, but we still need to understand learnings and we still need to understand how to improve it in the future. And that's what we did. So we have 4 major takeaways from this. 1, the system is actually working out of the box. So no code changes to Venus were required. There was no downtime. Everything was fine. Good learning. It means that our foundation is solid. It means that a lot of these 5 things that we tried to achieve, we actually did achieve right off the bat. 2, liquidators didn't need to change their infrastructure. Fastlane has got actually a very, very good liquidation bot, which is open source on GitHub. You can try it today. But if you are already a liquidator and you run your own liquidation bot, you don't have to change that. You just need to tell the bot, instead of bidding for gas, of just bidding in the auction. That's the only change that you need to make. Then, furthermore, RedStone handle the sequencing, the execution, the fallback mechanism all seamlessly. Sometimes we wanted to trigger a fallback just for the sake of seeing if that worked, and it did. And finally, there was real value that was captured in production safely and precisely, and then redistributed to the protocol and to the users. This shows that this whole system is not theoretical, it's actually something that is living and breathing in production, and it's already providing value to a lot of people. Integration for all of this is that simple. I'm going to tell you in the next few minutes how to integrate RedStone OEV into a protocol. So, step one, you whitelist as a protocol the RedStone relayer, and that's all. No step two. No code changes, no changes to the markets, no changes to the contract. If you're using RedStone feeds on your market, you just get OEV automatically. This is huge because it's a big differentiator for us in the market. We want to make sure that the life of the protocol is as easy as possible. And obviously, you may ask yourself, and you may ask me, who's benefiting from all of this, right? Who are the winners of having these OEV? You know, liquidation have been running for years, and MEV bots have been running for years. Why change it, right? And there's three main winners, and as you can see, liquidators are actually one of them. So the first winner clearly is the protocol, right? This effectively turns a byproduct into a revenue stream for the protocol. Protocol will losing on all of this revenue. It didn't exist, and we are creating it for them. What this means in practice is that this improves capital efficiency, so you can have better LTV, so you can have better APY, and therefore a better protocol. And therefore, also the users win, because they get a more predictable liquidation. They get less slippage, they get fewer surprises, and they have a better long-term borrowing terms from the protocol themselves, because they are effectively operating on more efficient markets. And finally, also the liquidators win, because now they get open access to the liquidation. They don't have to invest a lot of capital in gas and waste a lot of capital in gas. There is no white list, no co-location, no under the table or over the table shake of hand deal between liquidators and protocols, between liquidators and chains. Everything is open air and open source. You can run a liquidator if you want today, which I'm sure you could not have done before, because probably before it would not have been profitable for you to do so. The old system works better. It's just something that it was a problem that us in DeFi didn't talk about for a very long time, and now we're starting to talk about it, and we're starting to solve it. Obviously, if this was working on just one chain, it would not make a lot of sense. So we built it to support every EVM chain. And there will be non-EVM chains in the future, but for now, as I said, we're focusing on EVM. We are live today, July 2025, on Unichain and on BNB, and we are about to go live on Katana, on Hypercore, HyperEVM, and on Base. And then there will be more coming. Polygon, Optimism, Arbitrum, the one that you imagine. It needs to be scalable. So effectively, this happens within the same architecture, with the same logic. So the liquidators bot, actually, they get also an abstraction layer so that they can liquidate through our open source liquidator bot everywhere. And more importantly, in order to make this integration on our end, so to go to a new chain, it takes about 10 days. So this is not a long process with a slow rollout, a phased rollout. We are pushing the chain out one after the other. And the reason why we're doing it so far in a conservative manner is because we wanted the product to be perfect. Now that it is, the rollout is super, super fast. So BNB, Unichain, and then Hypercore, Base, Katana, Polygon, Optimism, Arbitrum, more. I talked about RWA before, and I want to close with a little about why this is important, not only for retail investors, but also for institutions. At RedStone, we just published our RWA report, which is more than 60 pages of details of why we believe that RWA is the future of the DeFi expansion. And I would encourage you to watch the recording on my other talk about that. But how does OEV help with that? It's something that we ask ourselves, and it's something that I want to tell you. Institutions, as you know, they are very risk adverse. They want to avoid unexpected losses. They want to make sure that whenever their money is on chain is as safe as it could possibly be. And with OEV actually can be, because you are getting effectively an additional security layer on top of your investment. You get instant liquidations, you get a plug-and-play security. There's no gas war. So therefore, by having faster, more accurate liquidations, you have access to safer looping. And by having safer looping, you have a higher LTV, so a more competitive APY. So it's not only good for security, but it's also good for profit. So we truly do believe that OEV is crucial, and we truly do believe that the protocols that are going to adopt OEV the quickest are going to be the ones that are going to be advantage in this big RWA institutional move that's happening in DeFi. Thank you so much for your time. It's been lovely talking to you. If you have any questions, please do reach out to me on my Twitter at mkmassari, or you can follow us at RedStone DeFi. If you have any question now, I'm happy to answer them. Otherwise, thank you so much for your time.